that's the beauty of this prototyping system, is the fact that you can stack all of these shields on top of each other and just expand what you're doing into infinitum, basically. Like I said, the only real step back on the Arduino system is the fact that you can only run one process at a time. Now, there is a programming technique called interrupt, where you can actually stop the programming, because like I said, it's running completely in a loop, and it's one single loop, but you can also run different protocols off of that loop, and you can do interrupts. And there are 2 pins on the Arduino board that allow you to do interrupt. And it basically stops everything it's doing, runs a whole new program, and then goes back to its original program. And that's especially good if you're wanting to use this for like home security or home lighting or whatever. You want to stop the air conditioning and then turn on the lights and then go back to the air conditioning. And one of the neat things about Arduino, and I didn't really touch on this yet, but the system is pretty much endless in what you can do with it. If you get online, if you get an opportunity to get on YouTube and search Arduino, you're going to find about 10,000 videos of people using this from everything from remote control cars to webcam systems and setups where you can actually control the remote control car through the internet over a webcam. There are segways, because you can actually get this and get a G-sensor and a gyroscope, and you can build your frame and put your tires on, your motors, and you can actually control a vehicle. And I've seen remote control helicopters that run off of this system. So, whatever you can think of, you can do. And one of the things I want to do is actually build a submarine, with lights and a camera and everything that's controlled by Arduino. And but yeah, there's all sorts of things you can do with it. And I actually built that car this afternoon. That's why it's not super polished, but it allows you to kind of see some of the motor controls and things like that. So, like I said, this right here was the DMX shield. This actually, as a kit, I bought all of the parts from Mouser Electronics, and I bought the board from CuteDigi.com. And it actually allows you to control up to 255 channels of DMX. So if you were to go into a theater and you wanted to control your red, blue lights and your strobe lights and everything else, you can do that with this. It would work great for Halloween. I've actually got dissected on my workbench at home a Furby, and so I'm looking forward to making a demonic Furby pretty soon. So
wouldn't take much.
Yeah, it wouldn't. But anyway, you're welcome to come up here and check this stuff out and play with the sounds of the trail exhibit. If you have any questions, I can still elaborate on any of the points that I've covered.
How appropriate would this be to be taught in a class? Seems like it would be really pretty easy.
It is very easy. Like I said, I picked it up just, a friend of mine, his name is Clinton Johnson, he's actually an IT over at the Comanche Memorial Hospital. He suggested this to me one day when we were working on a couple of projects, and he said, you got to try this thing, it's cheap, and a lot of the things that are in my kit here are all stuff that I've taken from other projects and other things. You have a dead mouse, you pull out the sensors out of it, and you use the parts. And like I said, the nice thing about it, of course, is it's prototyping, and one of these kits in your classroom, any classroom, really kind of opens your mind to the kinds of things you can do with electronics. And I'm just working with this system and playing with the different projects. Blinking LED, isn't magical to everybody, but the first time you make something blink, it kind of opens your mind to, well, if I can make an LED blink, what can I do with a motor, or what can I do with a servo? There's little robots all over the internet that people have built with Arduino, because it doesn't weigh very much. So you put a couple of servos on it, a couple little springs, it's awesome. You can make cars, interactive games such as that. There's actually LCD monitors you can get for it, so you can actually do interactive games like Pong. There are shields with joysticks, so you can actually control games with it. I've actually seen a Game Boy built on the Arduino, so you could actually play Tetris, and you could have sound and everything with it. So yeah, there's absolutely no reason why you couldn't have this in a classroom. and like I said, the great thing is, when you get these little tutorials, it's pretty easy to see where you plug into, and it tells you which resistors to use. I know I learned a lot about what the stripes on resistors mean, so I know which resistor to use with LED lights. You learn a lot from the book itself. Will tell you, don't put this in backwards and don't do this. And you learn which side of the LED is positive and which one is ground. And there's a lot of educational things you get when you play with this kind of kit. I know a lot of people kind of grew up. I grew up with the electronic kits that were, they have the big springs and you slide the wire in, and then you get a piezo buzzer and a couple things like that. But this gives you full control because it's a microprocessor. You get to tell it what it's going to do. You can tell it to light up. You can tell it to wait 20 seconds to do something. You can build clocks with it. One of the things people are doing a lot these days is taking pixie tubes and making clocks out of them. Yeah, it's a really neat thing, and the great thing about it is you can start small with a breadboard setup like this and go to the professional version after you prototyped it. You can actually sell your product. There's a website called Pinoko.com. It's Pinoko.com, and they actually have partnered with SparkFun.com. I've plugged them a lot today. But you can actually have your own custom enclosures built, and you can actually design your project from start to finish. You send an EPS file with a certain color in your lines and a certain thickness in your lines. And they do all of your laser etching and cutting for you, and then they will ship you all of your parts you need. So if you needed a buzzer, a potentiometer, some LED lights, 15 resistors, 15 headers, a wave shield, whatever, it all comes in one box. And it's really cool. And I've actually I've got a keychain that I had done at Pinoko. It's just a laser etch thing, and you can do jewelry and stuff there. But they do wood, metal, acrylic, and there's a couple other materials, leather. So you can do pretty much whatever you want. You can do custom Christmas gifts. If you wanted to make a Halloween, a pumpkin that jumps up and yells and screams or whatever, you could get the parts and stuff from Pinoko for that.
You might mention the cost to get started.
Yeah, I think that this runs about $54 for the basic starter kit. The Arduino, the standard shield, it runs $25, and then the Mega is, I think by itself is $54 for the Mega. Of course, you get so much more with the Mega. The shields. Most of the shields that are on the market are designed for the Delamob and the Uno because they fit the pinouts correctly. But there are shields for the Mega, and the shield that's actually in this unit on the Mega is actually a Mega prototyping shield.
So when you were a brand new newbie, how long did it take you to figure out how to make the LED blink?
The nice thing about it is excuse me. It's really quick and simple. I had a blinking light within an hour of pulling it out of the box. The website is arduino.cc, and on that website is a huge knowledge base and a huge list of tutorials. Since it is an open source application, an open source system, everything is free, and it's out there and easy to find. And pretty much anything you can think of doing, somebody else has probably already done it. And you can take their code and rewrite it to fit your needs. Obviously, every application is going to be a little bit different because of the fact that you have different pinouts that you're going to use. But yeah, I was up and running within, an hour of getting it. Probably within the first 15 minutes, really. Because the first program, the blinking light, you can actually run directly off of the board without anything but an LED. And actually, you don't even need the LED because the board has an LED built onto it that you can play with. The board also, when you get to the prototyping board, it actually has 2 LEDs already built onto it. You can actually control, because they're already connected to pins, and it also has a push button. So with a prototyping board right out of the box, you can already make interactions. And basically with the prototyping board, just like with the starter kit, you just take your wire, and this actually came with these pre-built wires. You plug it into the pin you're going to use, plug it into the part of the breadboard you need. We'll take your LED lights. Take the positive. Run a second wire over to ground. And they're all labeled, so you're not going to plug into the wrong hole. Now, if I were to plug this into the Arduino and set a program that says digital write, and then the pin number, which is, I'm using pin 10, I could turn that light on. That's all it takes, is one little line of code that says digital write, pin 10. It's very simple. And then to make it blink, you just put a delay in for, say, 50 milliseconds, and then you put in another line that says digital pin, or digital write, and then off, and then pin number. So it's very simple, and the programming language is incredibly easy to use.
One more question. You said, is there a shield to do gyros?
Yes.
Okay, so you could, okay.
There's a shield for pretty much anything. There's one that you can get at Arduino at SparkFun that's called 5 degrees of 360 degrees of freedom, and it's you attach it, and it actually gives you a gyroscope. It's got a heat sensor. It's got it's just a whole bunch of sensors built into it, so you can use it with a weather balloon or whatever, and it gives you back all the feedback.
This project you've done on house kind of stuff, the games. It's controlling, say, like I said, driving in and controlling equipment, as they keep talking about now.
That's probably the biggest thing I've done. I've got bigger aspirations. We're planning to do a big Christmas display this year, and so we're going to have a lot of lights and everything. We're going to control it with power switch tails and the Arduino. We're going to set it up. You can get a sound sensor, so that it actually can tell highs, mids, and lows. And so you can set which lights are going to go off, or which Arduino is going to control which sets of those lighting based on the tones. And so that's how I'm going to set it up. So we can play Christmas music, or and you could do Halloween. You just end up with Halloween. You play some Michael Myers music, and you've got pumpkins lighting up across your porch. And the neat thing is, with every single one of those, you can have 15 pumpkins on your porch, and each one of them could light up in sync, or every other one, or however much power your house wants to put out, I guess.